Alright guys, in this video we're going to work on the chapter 8.1 conic sections and parabolas. In this video we're going to talk about parabolas, and then we're going to continuously working on the section 8.2, which is about ellipse, and 8.3 hyperbola, 8.4 okay, up to 8.3. Alright, so we're going to finish up to 8.3, and then we are done for our conic section. And then we're going to, go to the chapter 6 to work about vectors, as I mentioned before. Okay? So, for now, we're going to talk about the meaning of conic sections. You guys have heard about conic sections before, right? But you may don't know what that means, right? So, here is the explanation that how we can make a conic section. So here, imagine two non-perpendicular lines intersecting at point V. Please look at the figure 8.1. So if we fix one of the lines as an axis and rotate the other line, which we call the generator, around the axis, then the generator sweeps out a right circular cone with vertex V. As illustrated in figure 8.1. So, notice that a V divides the cone into two parts called naps, which with each nap of cone resembling a point of, which is a point in ice cream cone. So, conic section now, or conic, is a cross section of a cone. In other words, the intersection of a plane with a right circular cone. So the three basic conic sections are the parabola, the ellipse, and hyperbola. Actually, we can find out circle as well. So, but the circle, they don't really introduce you how to do it. But usually when they're talking about the conic section, they would talk about circle as well. So if we have a chance, we're going to talk about circle briefly. Okay. So, you're going to look at the how the conic sections look like. So please look at the picture on page 581, and if you are make the plane cross to the upper or bottom of the cone slightly, then we can make an ellipse. Now the degree is gonna be more deeper, and then that's exactly same slope of the one side of the line, which we call the axis, right? And then you can make a parabola, and then the hyperbola is gonna be your plane intersected the cone, which is perpendicular. And then you can make a two waved line. That we call the hyperbola. And then the line exactly passing through the vertex V that we call the point. And then if you have a plane tangent to the cone, that's we call the single line. And then intersecting lines. Okay, so now we're going to talk about parabola first, all the way bottom in definition section. A parabola is the set of all points in a plane equidistant from a particular line, which we call the directrix, and a particular point, which we call the focus in the plane. So please look at the picture of 8.3 right here. Then we can see the parabola. As you see in the figure 8.3, the line passing through the focus and perpendicular to the directrix is the focal axis of the parabola. The axis is the line of symmetry for the parabola. So the point where the parabola intersects its axis is the vertex of the parabola. So, you guys are familiar with the parabola because we guys learned the quadratic, function, right? But their name is a little bit different because we terms of in the conic section. But if you are thinking about the quadratic function, and quadratic function has an axis of symmetry, right? That's we call the axis, and then we have a vertex, right? And then maybe the new thing would be the focus in here, and then directress, of course. But just think about the shape of a quadratic equation, then quadratic function, that you can easily think about parabola. Okay, so you have to remember the vocabularies, of course, which is a directress and then the focus, and I think that's the new vocabularies in here. All right, for now, we're going to find out the standard form of parabola, because this section, it's not that hard, but it is annoying because you have to memorize all of them, which is your focus and directress, how we find that. That's gonna be a trickier part, and then they have a translations as well, and you guys have a parabola, hyperbola, ellipse. They have all different formulas, which means you have a lot of memorization. So you're going to pay attention then how we can make it, so that you are going to not really much time to memorize all the things. Okay, so I'm going to guide you to how you can derive your formula based on the basic one, so that you don't really have to memorize all of that. Okay, so in here you guys are going to see the standard form here, which is the equation x squared equal 4py is the standard form. Okay, so think about it. You have a y equals x squared, and you have your a is positive, and your graph is opens up, correct? So samely, when you look at the figure 8.58, that's a situation that your p is bigger than 0. So in this time, we are not having a, we are having p. So your p is positive, which is bigger than 0, then your graph opens up. And your p is less than 0, then your graph opens down. You guys may see that the figure 8.5 easily, right? And then your focus is always on the axis. So as you know, the line of symmetry, when you are having the opens up, that's gonna be the y-axis, right? So you guys have a focus on 0, p. And then your directress needs to be the line which is same distance from the vertex. So that would be y equal negative p. So remember, your another set of parabola would be y squared equal 4px, which is opens right or left. Your directress is going to be changed into the x equal negative p, x equal positive p. Okay, so when you are having the graph opens up or down, your directress would be y equals negative p, either y equal negative p, but your p would be negative or positive depending on what you have. So that's the standard form. What is a standard form? X squared equal 4py. Now, there is a new vocabulary, which is a focal length and focal width. So when the equation of an upward or downward, which is the opening parabola, is written as x squared equals 4py, that's what I just mentioned, and then the value p is interpreted as the focal length of the parabola. So the directed distance from the vertex to the focus, that's we call that as a focal length. Okay? And a line segment with endpoints on the parabola is the chord of the parabola. The value, absolute value of p, for p, we call it as a focal width. So once you can find p, and then you times 4, and then you can put around absolute value on it, that's we call it as a focal width, which is a meaning of the length of the chord through the focus and perpendicular to the axis. That's we call as a focal width. Okay, so you have to remember that your equation looks like y squared equal 4py. That's what we are already familiar with the quadratic function. That means upward or downward. Otherwise, your y has a squared with it. That's gonna be what opens left or right. So please look at the green picture, guys. So the standard equation, x squared equal 4py, y squared equal 4px, right? And then the second part is open. So if you have upward or downward, that is x squared equal 4py. To opens to the right or opens to the left, that's we call it as a y squared equal 4px. Now the focus. So your standard form of this parabola is focus always on the y-axis, which is a 0, p. But the opposite case, which is your graph is opens to the right or left, your focus needs to be located on the x-axis, which is a p, 0. Now, as I mentioned, directress. If your graph is opens up or right, your parabola opens up or down, and your directress is y equal negative p. Otherwise, your graph is opens to the right or left, your directress is x equals negative p. You have to remember, okay? The axis, I talked about that already. If you have opens up or down, y-axis would be your axis. And then if you have opens to the right or left, your axis would be what? X-axis. Now, focal length is always p. What does that mean? The directed distance from the vertex to the focus. That's what we call it as a focal length. That's just p self. And the focal width. What was the length of the chord through the focus and perpendicular to the axis? That's what we call it as a focal width. That's always absolute value of 4p. Alright, now we are going to use this information to solve examples. Okay, so let me open my whiteboard. Okay, so we are going to talk about example 1 on page 584. Excuse me. Okay, so example 1. So finding the focus, directress, and focal width. So you have to pay attention that the formula, right? And then you have to look at that is gonna be opens up or down, left or right. So what was the basic form of this parabola? Which is x squared equal 4py. That is our basic, which is the standard form, correct? Standard form. So look, your example 1 is this: y equals negative 1 over 3x squared. Oh yeah, I am really familiar with that because that's a quadratic, function. But my basic, which is standard form, should be x squared equal 4py. But I have a negative 1 over 3 here, which is not exactly matching it. So you are going to what? Times negative 3 each side. So that I can cancel that one out. Then I have y squared equal negative 3y. Guys, which one would be your 4p? Here, your standard form is y squared is 4py. Actually, this negative 3 should be same as what? 4p. So I can say my 4p would be negative 3. Then I can get my p divided by 4. Then my p would be what? Negative 3/4. That's my p. Once you get your p, you are good because you just plug everything into the formula. That's it. Okay? So now, as I mentioned, this is x squared. So your parabola is what? Upward or downward? We can talk about that. But look, your p is negative. So your parabola is gonna be opens what? Opens down. Okay? So you can expect that your parabola looks like this. You're having the axis right here, and your P equal negative, what was it? Negative 3/4? Yeah, 3/4. Negative 3/4. So where is my P then? This is negative 0.5. And I would have my negative one right here. Then, that's my P. Let's say that's my P. Then, your graph, we don't really have any transformation yet. So your graph looks like that. And then your directrix is right here, which is the same distance of it, which is y equals what? 3/4. So this is 1. And my directrix is going to be passing through here. What? Y equals positive 3/4. That is going to be my directrix. Okay? And then P. What is my focus? 0, comma, negative 3/4. Alright, so I already got it. So, first I have to find my focus. That's my answer. That's my focus. So remember, your parabola opens up or down. Your focus always 0, comma, P, which is 0, comma, negative 3/4. Now, my directrix is y equal negative P, which is y equal 3/4. Now what? I need to get my focal width. Focal width. What was the formula for focal width? That was the absolute value of 4p. So absolute value of 4 times negative 3/4. That becomes just 3. That's the answer. Alright? Okay, so I want you guys work on exercise 1 on page 584. Page 587. Alright, so please pause this video to work on number 1, and then you guys may check the answer with me. Okay, so page 587, number 1. X squared equals 6y. Alright, so since x has a squared, which is your parabola opens up or down, right? So, what was the standard form again? X squared equal 4py. Okay, that is easier than our example because it's really closer to standard form, which means my 6 should be same as what? 4p. So 4p equals 6. My p divided by 4, then it would be 3/2. Now, what we need to looking for? What are we looking for? We need to find the vertex and the focus. Oh, did I mention the vertex before? Did they ask the vertex on example 1? Oh no, they don't. Alright, so vertex is easy because 0, 0, because this is not translated yet. So every single time it will be 0. So my first vertex, 0, 0. Now, number 2. Focus. Since this one opens up or down, actually it is opens up because your P is positive 3, a positive number. Now, your focus would be 0, 3/2. That's my focus. Now, number 3. What are we looking for? Directrix. Since your parabola opens up, your directrix would be y equals negative p, which is negative 3/2. Are you guys with me? Now, focal width. What was the formula? F's value of 4, P. 4 times negative 3 over a positive 3 over 2. So 2 is here, which is 6. That's the answer. Okay? Alright, let's go. So we're going to go to example 2 now. On page 584. Alright, now page 584, example 2. Find the equation in standard form for the parabola whose directrix is the line x equal 2 and whose focus is negative 2, 0. So that is a focus. That is a directrix. So from here, what should we be looking for? We always need to find out our P. That's my first. So now, their focus is negative 2, 0. Oh well, what do we find? I have an x and my negative 2 is on my x-axis. From here, I can think about that my parabola opens to the right or left. That's what I can think about it. Then what's gonna be the standard form of opens left or right? Y squared equal 4px. That is a standard form you have to find out. Correct? Now let's go back. What's my P? This focus itself is P already, right? So my P would be what? Negative 2. So I can write it down my answer, which is y squared equals 4 times negative 2 times x, which is y squared equal negative 8x. So, that's it simply. We have to look at that our focus is a 0, something or something, 0. That directly gives us that your parabola opens up or down, left or right. In this case, parabola opens left because your P is negative, right? So once you're having P as a positive, opens right. Your P is negative, opens to the left. All right? Okay, so this is our last question. I need you guys to work on page 588, number 15. So please solve this question and then let's check the answer together. Alright, number 15. So what do we have? Focus is 0, 5 and directrix is y equal negative 5. Alright, since I have a focus as a 0, p, this is what opens up or down. What's gonna be the basic, what is gonna be the standard form? X squared equal 4py. I told you, think about the quadratic formula. Quadratic formula has x squared in it. Now what? This 5 is directly p. And checking on it, your directrix is y equal negative p, which is negative 5. Looks good. So now I just plug into the 5 into p. That's it. So my answer, x squared equal 20y. That's it. That's how we get our standard form of this parabola. Alright? Okay, I hope this video helped you understand. We're going to see in the Zoom class tomorrow. Alright, bye guys.